For this lesson, we're going to be taking a look at dividing fractions and then also adding and subtracting fractions. Now, previously we saw that multiplying worked out pretty well because you could just go straight across the top and straight across the bottom. Additionally, we had a way of simplifying our fractions early so that way we didn't have to work with larger numbers. Now, with division, normally you could go straight across the top and bottom like you would with multiplication. The problem with that, however, is the fact that, well, 3 divided by 10 is really nothing. Or if you turn that into a decimal, you can get a decimal value, but that doesn't really work out too well. And same thing with 8 divided by 11. Now, there is a kind of unspoken rule with fractions, and that's that you never mix decimal or results with remainders with fractions. You want to avoid that if at all possible. So we need a system that works great here. Now, there's actually two ways that you can do this. Some of you might remember of a method called cross multiply, and others of you might remember a method called keep, change, and flip. Now, they both do the same thing, but the better method here is to do keep, change, and flip. Now, just to show you that they both give you the same result, let's start off with the cross multiplying way, because that's the way most of us probably learned it in school. With cross multiplying, it does matter where you start. So we can either start at the 8 and multiply up to the 10, or we can go from 11 and multiply up to the 3. Now, only one of these will actually give us the right answer. So take a moment and think about what you think it is. And the correct answer would be that we actually got to start at the 11 and multiply up across to the 3. Now, this is a little bit counterintuitive because we read from left to right, and this is going from right to left, but this is the way we have to do it. So 11 up to the 3, 10 down to the 8. So 11 up to 3, that's 11 times 3, so we get 33. And then 10 down to the 8, that gives us 80. This problem can't simplify, so we can leave this as is, and we'd be fine. That would be the correct answer. But there is a other way to do this. So resetting the problem here. Some of you might remember a method called keep, change, and flip. Now, personally, I actually like this method a lot. And the reason for it is, for one thing, you don't have to remember a direction like you do with the other method, where you have to go from right to left. In this case, it tells you the order to do each step. So what we do is each step is a reminder of what we're going to do here. We're going to keep the first fraction exactly the same. We're going to change this problem from division into a multiplication problem. And we're going to flip the second fraction upside down. So keep, change, flip, or some people remember KCF. So what that becomes is 3 eighths. But now we're going to have times instead of divide. And we flip this upside down to give us 11 over 10. So when we do that, we get 33 over 80, which is the same thing we got last time, but this method is a little easier to remember. So if you're going to choose which method to use, I strongly recommend keep, change, flip. And the reason for that will be apparent here in our next example. So in our next example here, we have a case where we have some very large numbers. And this is why you don't want to use the cross multiply method. Because if you use cross multiply, you have no choice but to multiply up across the 121 times the 14 and the 7 times the 33. Now, you could do that. The problem is the result is going to be a lot more difficult to check this for simplification, and so we don't want to do that at all. Okay. So let's go ahead and back it up a bit. let's use the keep, change, flip method. So keep, change, and flip. We'll keep it as 14 over 33. We will change it to multiplication. And then we will flip that fraction upside down, and we get 121 over 7. Now, this is still an ugly looking problem, but I can see here that for 14 and 7, well, 7 comes out of those. And it might be a little trickier to see here, but 33 and 121 are both multiples of 11. So we can actually divide both of these by 11. And so now we have 2 times 11, which is 22. And it's over 3. So in this case, it turns out to be not that bad. If you keep change and flip, you can use all our other tricks because it turns it into multiplication. So in a way, you can almost think about division as multiplication, but with an extra step. You've got to get it to that multiplication first, and then it works out a little more simply. So let's take a look at a case where we have mixed numbers, and we have a case of dividing by a whole number here. Now, same rules as before, keep, change, flip. But here's the thing. You have to change these into improper fractions first. So anytime you have these mixed numbers, turn them into improper fractions before you do any of the math rules with them, because otherwise you're going to get a little bit mixed up. So for this one, we have 5 times 4. That gives us 20. And then we're going to add the 1 to it. So we end up getting 21 over 4. Okay, it's still division. Thing about whole numbers is that you can always write them as fractions. Now, the trick to this is actually really easy because fractions are really just another way to write division. So 21 over 4 is actually the same thing as saying 21 divided by 4, but we leave it as a fraction here. So in this case, 3, I mean, it's not being divided by anything unless you think about it as being divided by 1, because 3 divided by 1 is still 3. So the trick is, if you have a whole number and you need to do a fraction problem, you write it as a fraction by putting it over 1. Okay, so from here, we'll do what we just learned before. Keep, change, flip. 21 over 4 ends up changing and flipping. So we have 21 over 4 times 1/3. So we can see we cross out here. 3 goes into itself 1 time, and 3 goes into 21 7 times. 7 times 1 over 4 times 1, we get 7/4. And remember that you do not have to change these back into mixed numbers. It's fine to leave them as improper fractions. They'll still work out. You'll be fine, and you can move forward from there. Okay, so here are the example problems I want you guys to work on. So pause your video now, and we'll resume in 10 seconds. Okay, so again, the trick here, keep, change, flip. So when we do that, we get 2 over 7 times 5/3, multiply across, and you get 10 over 21. For the next one, keep, change, flip, 3/10 times 16 over 9, And here we can see that we have common factors we can take out a 3, and take out a 2 here. And we find our answer is 8 over 15. Final one. Remember, whole numbers can be thought of as over 1, so I'm going to do that right now. 9 times 6, that's 54, plus the 1 gives me 55 over 6. So this is the same thing as 55 over 6, and it's in the keep step, so don't have to change it again. We're going to change and flip. 55 and 5 both have 5 in common, so we cross them out. We leave behind 11 here, leave behind 1 here. Our final answer is 11 over 6. So that's pretty much all you need to know for dividing fractions. Our last set of rules here are adding and subtracting fractions. Now, something to note about this is that both adding and subtracting actually have very similar rules. The only difference is in the end you add or subtract. But you can't just add the way they're written. Okay? You cannot just add straight across the top and straight across the bottom. Remember, that's the rule for multiplying, but this isn't multiplying. So it turns out that there are several rules that we have to look at when we are trying to add and subtract fractions. And so we're going to go ahead and go through and list the steps for this. The first rule is that the denominators must match before you can add or subtract. So you notice in this case we have a 2/9 and we have a 1/6. The denominators are the bottom numbers. They don't match, so it's not going to work out here. So what we do instead is we find the lowest common denominator. Now, don't confuse this with simplifying fractions. Okay. For example, here, 9 and 6, they both have a common factor in 3, but you are not simplifying. So it can't be 3. Okay. The lowest common denominator is always going to be a larger number, not a smaller one. Okay. So what you do is you find the first number that both 9 and 6 can multiply up to. Now, in this case, it turns out the LCD for 9 and 6 would have to be 18. So we're going to use that. Okay. Make a note. We're looking for 18. So once we've found the lowest common denominator, the next thing we do is we multiply the top and bottom of each fraction to match the denominator to the LCD. So here's how that works. We have a 9 in the first fraction for the denominator. We need to match 9 to 18. So what we do is we actually end up multiplying the top and the bottom of this fraction by 2. Again, because we want to match the bottom to 18. So we'll go ahead and do that. And of course, doing that gives us a value of 4 over 18. Now, same idea, but this time we're going to go with the 6. To match 6 to 18, we need to actually multiply by 3 instead. So we'll do that. Top and bottom, multiply by 3. And when we get that, what we'll find is that from here, we can go ahead and continue our problem, because what we'll get now is 3 over 18. And both our bottom numbers match at this point. So we're in good straits here. So our final step is Once the bottom numbers match, you add or subtract the top values only, but the denominators stay the same. Okay, so once you got in the match, you don't change them again, you just go straight across. So that gives us a final answer of 7 over 18. So to recap, when you are adding or subtracting, you have to match the bottom numbers. To do that, you find the first number they both go into. So 9 and 6 both can match 18. Remember, it can't be 3 because we're not simplifying, we're finding the lowest common denominator. That's a larger number. Then you multiply the top and bottom, so that way the bottoms become 18. That's the key thing there. And then you can add across the top and get your final answer. When you're dealing with mixed numbers, you still do the same thing that we did before. So previously, right, with adding, we matched the bottoms and then we add across the top. Now, as you might expect, you can work these out the same way we did before, where you take 6 times the 8, that would give you 48, and then you would add the 7, and so on and so on. Okay, that still works. But there is a shortcut to this. Now, what I want to say is that you should only use this shortcut if you're really good at keeping your rules straight. If you think you're going to confuse things when you are doing this, then just do it the old way. Okay, the 6 times the 8, add the 7, right, and so on. But when you're adding and subtracting fractions, and only when you're adding and subtracting them, so no multiplication, no division, you can actually break this problem up as the whole numbers and the fractions as separate things. So you can do 6 minus 3, and you can take 7/8, and you can subtract a half. Again, this only works for adding and subtracting fractions. Now, doing that, 6 minus 3 gives you 3. So we know that 3 is going to be in our final answer. And then here we have a case, we have 7/8 minus a half. Now remember, the lowest common denominator is a value that they both can match. And so 6 and 8, a lot of people say 16. Now 16 would work, but you would have to simplify in the end. Don't forget, a number can go into itself, and it also can count for lowest common denominator. So it turns out 8 and 2 can both go into 8. So when you're getting your LCD, you actually want to use 8 for this. So that means this one, we're going to multiply, and I know it seems dumb, but still going to show it. 1 by top and bottom. And I'm going to multiply this one by 4. And that gives us a new problem here. 7/8 minus 4/8. Subtract across the top only. We get 3 over 8 for the final answer. If you had gone the other way, like I said, you did the 6 times the 8 to get 48, and then you added the 7 to get 55, and you went down that route, you would get a slightly different answer, but it would be correct. So just note that if you are comparing notes with someone, if they did it differently than you, you might get slightly different answers. So 3 and 3/8 works. But if you like to do it the other way, what you would actually end up getting instead is 27 over 8. Now, these are actually the same thing, but you only need to give me one of them to be considered correct. Go ahead and try these problems. Note for the second one here, yes, you have 3 fractions, but the concept for lowest common denominator is the same. You want to find a number that both 3, 6, and 4 can all multiply up to. So it would be common between all 3. Go ahead and pause the video and resume in 10 seconds. Okay, just like we did with the previous problem, we got to find the lowest common denominator for 12 and 8, which turns out to be 24. So Remember, you want to match the bottoms to that value. So we multiply this fraction by 2 and this one by 3. So 22 over 24 minus 15 over 24 is equal to 7 over 24. For this one, again, same concept, 3, 6, and 4. Turns out their lowest common denominator is 12. So we will multiply each of them. The first one is going to be multiplied by 4 to give us 4 over 12. The next one is going to be multiplied by 2 as we match that 6 up to give us 10 over 12. And finally, for this one, we're going to multiply the 4 by 3, so that would match 12. 3 times 3, so that gives us 9 over 12. Just note, if I ever write something like that, I intend 9, not 4. My 4s always look like that. My handwriting is bad enough as it is. So we add those up. 4 plus 10 is 14, plus 9 is 23, and it's over 12. Last one here. And again, remember the trick. We can add the whole numbers as separate things. So I already know 4 plus 1, that's going to give us 5. So we only really need to look at the fractions on their own. So we get 2/5 plus 7/15. The common denominator between 5 and 15 happens to be 15. So we multiply by 3 here. That gives us 6 over 15 plus 7 over 15. And so we add those to get 13 over 15. And that's it. So those are your fraction rules. I strongly recommend that you guys practice those fraction rules on the homework as soon as you can. Even though the homework is only going to be due in a week, so you have plenty of time still, do a little bit of this. You're going to see that the quiz that is going to come out on Wednesday is going to involve about 50-50 fractions, and the other half is going to be the next types of problems we're going to work on the final video for tonight's lecture.